Hello everyone, myself Dr. Abhishek Kumar from Department of Civil Engineering, IIT Guwahati, and I am the instructor of the course Applied Seismology for Engineers. The course is designed in total 30 lectures where you will be getting the details related to different layers of the earth, what are the physical and chemical properties of these layers, then in terms of physical properties, how the convection current is coming into picture in order to induce movement beneath different plates. Across the globe, we are having major plates as well as because of generation of stresses within the plates, there are development of small plates or subcontinental plates. If you club all these plates, you can get the entire periphery or the circumference of the Earth. Depending upon the dominating direction of convection current, whether it is inducing the movement towards both the plates, you may have convergent plate boundaries, where usually the softer plate subducts under the older as well as relatively stiffer plate. On the other hand, you are having sometimes continent as well as continent for the subduction. So the boundary will be called as subduction boundaries, continent subduction boundaries. And usually it is seen at times when the plate undergoes the other plate at certain depth, after reaching certain depth, because of significant increase in the temperature, there will be melting which will take place. And when this melted material comes onto the surface, there will be formation of volcanoes. On the contrary, when we talk about divergent plate boundaries, so there will be plates which are moving away from each other. That means the convection current between the adjoining plates are such that the two plates, rather coming in contact with each other, are actually moving away from each other. That is called as divergent plate boundary and is responsible for the generation of new landmass. Often we will see that there will be generation of continuous chain of volcanoes through which the molten material comes onto the surface, gets solidified. And since these plate boundaries are in continuous motion, you may see over some geological time scale, the material which was just deposited at the plate boundary will now can be found at certain kilometers away from the boundary, because this material is also in continuous motion due to convergent or due to divergent nature of the plate boundary. So particularly, if you look at divergent plate boundary, there will be generation of continuous mountains marking the presence of divergent plate boundary or generation of new landmass. On convergent plate boundary, there was consumption of landmass. That is why it is also called as destructive plate boundary. The divergent plate boundary is called as extensional plate boundary because you are extending the two plates and there is development of new landmass. Then there is third kind of plate boundary, which is called as transform plate boundary, where there will not be any kind of movement towards or away from the plate boundary, but the movement is purely in the direction, in horizontal movement, which is moving along the boundary of the plate. Usually these kinds of boundaries are present in order to conserve whenever there is different rate of divergence or convergence at two distant plate boundaries of convergent or divergent nature. In such a case, transform plate boundary will exist where it will be example of pure slide passing with respect to each other. If you see in plan, there will be two plates which are moving sidewise away from each, parallelly with respect to each other, where one plate might be moving faster than the other plate. That is called as transform plate boundary. Depending upon the type of movement along the plate boundaries, you can have different kind of mechanism which will represent the nature of movement on the ground surface. Additionally, these kinds of movements, whether the plate boundaries are moving towards each other or away from each other, can be detected from GPS measurements and even from in situ measurements along the surface of the earth. So standard maps are also available, which can give you what is the rate at which annually different parts of the globe are moving. These are in continuous motion. Then if you go beneath the ground surface, you will find different plates, different layers. That is, as upper mantle will be there, lower mantle will be there, then outer core, and then inner core. Inner core is solid and significantly high density, as a result of which the overall density of the Earth is found to be on higher side than the average density of the material available on the ground surface. Because of the convection current, it is found that different plates are in continuous motion with respect to each other. And if you relate this convection current, you'll find out that around 250 million years from present, entire landmass was a single landmass, which is called as Pangea. So this suggests that continents, what we are seeing today, these are in continuous motion, explained by continental drift theory, which is supported by similarity in terms of fossil findings across different continents, which are separated at present by thousands of kilometers. Similarly, you can find out same kind of mineral depositions, which is not possible if in geological time scale, sometime these plate boundaries, these land masses were in contact with each other. Same with respect to plant and animal fossil. You'll find some plant and animal fossil in two different continents in present configuration, suggesting that in geological time scale, these two continents must be in contact with each other, were completely in close contact with each other, such that the development of animals, movement of animals, as well as the development of same kind of plants was possible in some geological time scale. It is only because in the current configuration, these two land masses are significantly apart, we can understand that this can only be possible or can only be explained with the help of continental drift theory, which suggests that the land mass is in continuous motion. Then comes to elastic rebound theory, which suggests that up to the stage, because of plate movement, there will be continuous accumulation of strain energy. When this energy exceeds the capacity of the rock medium, the crystal medium, then the material will undergo failure. And this is what experienced across the globe in form of seismic events or earthquakes. So whenever the energy stored reach to a threshold value of the medium, so the medium will be also having some shear modulus. So when this energy exceeds the strength of the material, there will be failure. Failure will be in terms of, there will be some kind of melting, there will be in terms of rupture, which we commonly known as earthquake. So when earthquake happens, there will be development of seismic waves generated from the source. And these seismic waves start propagating from the source. So it will start from a point where the rupture process along the fault plane had started. Then there will be subsequently development of seismic waves. Once the rupture propagates to a larger area of the fault plane, you can see that there will be development of additional seismic waves because of the failure, because of the propagation of rupture to a larger area, which is controlled by the size of the earthquake. So in later stage, we have also discussed when we are trying to determine the size of the earthquake, particularly if you refer to seismic moment or moment magnitude, it is directly proportional to how much is the length and width along the fault plane which undergoes failure or which undergoes rupture. So if you refer to some of the recent earthquakes, you can find out that at times these rupture dimensions may vary in the range of 300, 400 kilometer by 100 kilometer, 50 kilometer, 60 kilometer. So this is the this figure just gives you an idea about what is the typical dimension of an area which beneath the ground surface is undergoing rupture to trigger a particular earthquake. And it need not be a great earthquake, even a strong earthquake or moderate earthquake can cause significantly larger area to undergo rupture. So depending upon the area undergoing rupture, will tell you approximately that is the duration for which seismic waves are triggered or seismic waves are produced from the rupture process. These seismic wave will start propagating in three-dimensional space from the focus or more specifically from the rupture location at any moment of time. It will start propagating in three-dimensional space, and wherever with respect to this epicenter the recording stations are available, we will be able to find out the seismic waves detected at the recording station. While I am explaining these details of the course, I will request the audience which are present to kindly put their questions in the chat box so I can read out the question and I can attend each of these questions in the live session. So we were discussing about the seismic waves. When the seismic waves propagate, these will also interact with the medium between the source as well as the recording station. Now this medium, crystal medium will be there. So depending upon the medium, there might be scattering because the wave is propagating in terms of pockets of energy and which is in the three-dimensional space. So there will be some kind of scattering happening, resulting in redistribution of energy. So you will find that as you are moving away from the point of initiation of rupture, the seismic energy or the attenuation of seismic wave is happening over the distance. Same when the seismic wave is propagating through a particular medium, depending upon the type of wave we take into consideration. Like primary wave, if it is passing through a particular medium, that will cause compression as well as rarefaction. If shear wave is there, that will cause shearing both in horizontal as well as in vertical plane, but perpendicular to the direction of propagation. Now, each of these kinds of waves, when passing through the medium, cause particle movement. Because of the virtue of movement of the particle, there will be development of heat. So some energy has gone into scattering, some energy has gone into heat, and in addition, there can be the medium can be also heterogeneous in nature, as a result of which there will be redistribution of energy. We see that whenever there is change in the stiffness of the medium, and then a wave is propagating through the medium, there will be refraction and reflection take place, as a result of which some portion of energy will be propagating to stiffer medium, some portion of energy will be retaining in the previous medium, and some energy will be reflected back. So as a result of this reflection and refraction, again there will be some reduction in the energy or there will be some redistribution in the energy over the distance. So if you talk about hypocenter distance, that means the distance between the point of initiation of rupture, that is focus, and your recording station, measured taking the focal depth into consideration. Along this propagation path, there is continuous redistribution of energy which the seismic wave is propagating or carrying, primarily because of scattering, then heterogeneity, and then heat. As a result, if you put two recording stations, very one close to the epicenter, other one far from the epicenter, you can notice that there is significant drop in the amplitude of the seismic waves. That is called as propagation path effect. And the route which the seismic wave is taking. So this procedure is happening in the three-dimensional space. And in order to describe the propagation path effect, we are mainly focusing on the epicenter as well as the recording station. So the path which is existing between the epicenter and the recording station. In that particular path, these three phenomena are happening, as a result of which there is each frequency of wave, there is continuous change in its amplitude. This can be also determined using quality factors, which we have discussed in the course, which will tell us, if you talk about quality factor for primary wave, then how much is the attenuation happening because of primary wave alone. Similarly, with respect to shear waves, similarly with respect to other kinds of wave, if you focus on any specific wave. So it's like some energy has been released from the source, and then this energy is trying to distribute in the three-dimensional space, and some portion of the energy is actually reaching your recording station. And in case of recording station, it will detect the the passage of seismic waves. So if primary wave passes through that medium, the sensor will detect that there is a P wave which is passing through the medium, followed by primary wave. There will be shear wave. So first wave will be primary wave, then second wave will be shear wave which will be propagating through the medium. And then after that, depending upon the relative position of recording station with respect to epicenter and the position of near surface material, you may encounter surface waves, which can be of the type love wave as well as Rayleigh wave. So love wave, we have discussed that it comes because of the interaction of particular kind of shear wave component and near surface material. So when this shear wave component interact with near surface material, you will have love wave which will have only the displacement in the horizontal direction. And the nature of that displacement is such that it exponentially reduces as you go deeper into the ground surface. So at the ground surface, it will be very high, but as you go deeper, it will be slowly smaller. The last kind of wave which will come into picture, it is Rayleigh wave. Rayleigh wave, as passing through the medium, that will trigger elliptical motion. So elliptical motion very much similar to if you drop a pebble in pond, the wave will be generated. So if you put a leaf, the leaf will undergo kind of rotation, partial rotation. That resembles the kind of elliptical motion which is triggered by a Rayleigh wave in a medium. So because generally it is considered that one component of shear wave is triggering to love wave, as we know that shear wave is causing movement in two types, that is SH wave and SV wave. So one is triggering love wave, other one is triggering Rayleigh wave. And Rayleigh wave is leading to elliptical motion. So as the wave is propagating in the direction of wave propagation, there will be development of elliptical motion, which will trigger motion such that it is resembling a rolling nature of the material through which it passes. Once the wave passes, the material will come back to its original position. There will not be any kind of permanent volume change. The volume change will remain constant. As the wave propagates, the material will come back to its original position. So depending upon the relative position of your recording station from the epicenter, sometimes you will have more component of body waves, that is primary and secondary waves, or you can have more component on a record, ground motion record, of surface waves. So surface waves at times can be more. On the other side, Rayleigh waves can be more. When these waves are propagating through the medium, we can, using the equation of motion, we try to find out the propagation velocity of primary wave, how to determine the propagation velocity of primary wave, how to determine the propagation velocity of shear waves. All these we have determined in the lectures. So you can go through the lectures to get a detailed discussion related to this derivations, which will help in finding out that for a given medium with known elastic constant values, how we can find out the nature of the amplitude of primary wave velocity and shear wave velocities. These will also help you in locating the epicenter of an earthquake. So there are a number of recording stations which are detecting primary and secondary wave. We can take the time difference at each of the recording station into consideration. So suppose there was an earthquake, and because of this earthquake, the seismic waves which were traveling in the three-dimensional space were detected at 3 recording stations. So we can take the time difference of recording time difference between P and S wave arrival. That means the time of arrival of shear wave, because these are second fastest reaching to the recording station. So these will be reaching later. The first one will be primary wave. So once the primary wave reach and secondary wave reach, so you can take the difference of these two, because rather than taking absolute value, we can take relative time difference. When the S wave came, how much before the S wave primary wave reach the recording station? So taking the time difference between the two, we can find out approximately what is the radial distance, keeping your epicenter as the center, we can find out the radial distance and mark a circle on a piece of paper. And the same procedure we can repeat for more other recording station, such that the position of the recording station should be close by. Otherwise, you will be able to develop 3 circles, but there will not be an overlap on these circles. So we have to have the position of these circles such that there should be a zone which is common to all the 3 circles which we are developing from 3 recording stations. Once we develop these circles, we will be able to find out the common area. This common area is indicating the potential region in which the epicenter of the earthquake is located. This can help in identifying the location of the earthquake. Similarly, if we can differentiate between the primary wave and secondary wave arrival velocity, and literature is available which can help you in separating the primary wave as well as secondary wave, so we can approximately establish what is the noise available because of other sources, what is the amplitude of actual wave. This will also help in understanding the dispersion characteristics of the medium if you go to the Rayleigh wave velocities. So and that's how other topics are there, which are there. I just try to give some overview about what are the topics which have been covered in the course. And so if you have any question, please put here. In case there is no question, then after some time we can close this particular live session. I'm just waiting for some questions from the audience. And keep visiting the course page. So in case you have any question during two live, your questions in the chat box or in the below the lectures, so that those can be addressed there itself. If you place it there, then maybe larger set of audience which might be having this query, they can also listen to this particular course and this particular query of yours and the response from my side on that particular query. That will be really helpful not only for you but even for larger audience. So keep attending the lectures as well as keep submitting your assignments timely, so that you don't miss any particular assignment and you will be able to finish all the assignment timely. I'm just there for a couple of more minutes. If you have any questions, do post the questions here in the chat box. And do let us know if you have any suggestions related to the nature of numericals which are given, or any other thing which you feel more explanation is required. Then we will try to see what can be done from our side, so that we can add more discussion to any specific point. The course is designed such a way we try to give significant details related to different topics in this particular course. So if you look at the course is designed such a way. We will start with very basics of plate tectonics, continental drift, elastic rebound, and then we are going even up to seismic microzonation, risk, and vulnerability studies. So covering all these topics in 30 lectures, ensuring the details, too much detail about each of these topics, it is impossible. So wherever it is required that certain topics should be discussed in detail, more emphasis has been given to some of the topics. But certainly it is not possible to give details of all the topics, because the risk vulnerability studies itself can be a separate topic. Microzonation itself can be a separate topic to develop an additional course for NPTEL or MOOCs. And same way, if you go with hazard analysis, if you are going with liquefaction assessment, I try to give in a couple of lectures, but if you look from steady state point of view and you try to explain about flow liquefaction, cyclic mobility, then we are also discussing about paleo-liquefaction, how paleo-liquefaction features can be identified, how these can be helpful to identify potential size of the earthquake, location of the earthquake. So all these topics we have tried to given you an overview about these, and we have also tried to elaborate by means of suitable numerical from time to time. Same with respect to seismic site classification. We try to bring the importance of 30-meter base average stiffness as a criteria for site classification. It can be based on SPT value, it can be based on shear wave velocity, and it can be based on other field measured parameter in order to help you in understanding what is the on and average site class of the particular recording station or your site, so that you can understand what is the relative stiffness of your site. If it is belonging to soft soil site, you can take appropriate measures, because soft soil site means it will definitely lead to more amplification. More discussion on effect of site in controlling the surface ground motion is given in local site effect or ground response analysis. So we have given detailed discussion on methodologies related to linear, equivalent linear, and nonlinear ground motion, ground response analysis. So kindly go through those also as well, which will give you a complete picture about how one can perform ground response analysis. Okay, so what are the methods currently adopted? You can go with relative time between primary and secondary wave in order to find out the location of the earthquake epicenter. As far as this particular course is concerned, I will suggest like you restrict to this particular method only in order to find out the location of the earthquake. But as I mentioned that whenever we are interested to find out the earthquake epicenter, I have taken into consideration that there is primary wave and followed by which there is shear wave, which are well identified in a record. If you take a particular record, again there are a number of ways by which you have to actually identify the primary wave portion, that means the arrival of primary wave and the arrival of shear wave. So methodologies are there which will help you in actually separating the arrival time of primary wave and arrival time of shear wave. So it's not just by looking at the record, but you have to apply those methodology, maybe signal to noise ratio and other methods are there, which will help you in separating. Once you are able to separate, then you can confidently say what is the time of arrival of shear wave, what is the time of arrival of primary wave, take that into consideration and then determine the epicenter distance for that particular recording station. So next question is, what research must be focused as per the current scenario in earthquake engineering? So depending upon which area you pick up, because a lot of work is there related to ground response analysis, a lot of work is there related to probabilistics, liquefaction, then considering lot of analysis is also another area in which one can focus on, which will be primarily on determining the dynamic cell properties. Same with respect to liquefaction, then development of design response spectra, because a lot of infrastructure development is going on in the country. So this is another area which is quite important nowadays. How at a particular site one can determine the seismic hazard, both at bedrock level and at any particular level, depending upon which the designer is seeking for. The designer is asking for site class A condition, what is the design response spectra? Same way, if you go with important structure, they can also ask you to develop hazard curves, which were discussed in the probabilistic hazard analysis. So hazard curve will be focusing on what is the return period of different frequency of ground motion. Further, you can convert those using Poisson model to what is the confidence or what is the probability of exceedance during a certain exposure period. So if you are designing a bridge considering for next 60 years, 70 years, and as a consultant, you are asked to give what is the most likely to occur ground motion. So you can refer to and find out maybe for specific probability of exceedance, what is the return, what is the ground motion through the hazard curve. That is another area which is picking up more, because more and more projects are looking for site-specific studies. So zonation, seismic zonation of the country, it is referred, but for very important structure, generally people go for site-specific studies where the topics like seismic hazard analysis is applied at the site-specific observations solely. Same with respect to risk and vulnerability studies. These are clubbed with respect to building classification, which can be obtained based on satellite data or building classifications, and then we can find out what are the locations which can be declared to be relatively safe in case an earthquake is going to hit. So even for city planning, we are hearing about proper city planning, mitigation studies, rehabilitation studies, and even for policy making. So there, entire work which is discussed in seismic microdonation, it is very important. So if any other question is there, please write in the chat box. This particular course or in general, I do not mention about any particular software which is reliable because it will not be good to mention about any particular software here. If you refer to, if I refer to my work, I'm directly going with the coding which I'm doing myself. So this is the only thing I can mention related to seismic hazard analysis. All things which are there from my research area, I'm doing my own coding. So that's the thing I would like to add here. But if you are going through any particular code or software, I suggest you try understanding how that particular software works. Otherwise, many a times you are having the result, but you are not able to interpret those results. Okay, thank you. And I'll stop here. As I mentioned in the beginning also, if you have any questions, queries, put on the portal so that we can address to those queries timely. And it will help other people also to understand this particular course topics. And in total, there are 30 lectures. So just follow the lectures, and I'll suggest because many of the lectures are interconnected. So whenever you are going for any previous lectures, so there will be continuity and there will be more clarifications. Okay, thank you.